All right, let's first look at a 2 by 2 matrix. Where A is equal to A, B, C, and D. Now, a determinant D is equal to AD minus BC. Think about it as a clock. You take and multiply this way, going, and you add them together. And then when you're going up in the opposite direction, it is subtraction. So it is A times D, and then you have to subtract out B times C. Again, as if you were drawing a circle. So if I ask you to go through and find the matrix, so given the matrix 2, 3, -2, 6, multiply. So my determinant is equal to 12, and then coming up from this direction, minus a -6, or the determinant of this matrix is just 12 plus 6, or 18. If I have a matrix that looks like this, which is -4, -2, 6, and 3, so the determinant of this matrix does something down, multiply. That gives us -12. And then when you come back around, you end up subtracting. So that's going to be minus a -12. This determinant is actually equal to 0. If we talk about what a determinant means as far as systems of equation goes, when a determinant is 0, what that tells us is that the system of equations is either dependent, where it has an infinite number of solutions, or inconsistent and has no solutions. Let's go ahead and look what happens about how we're going to do a 3 by 3 determinant of a matrix. All right, so a 3 by 3 is a little bit trickier. Let's start off, and we're going to go ahead and put letters in here for now. Let's call this matrix A, B, C, D, E, F, G, H, and J. We never use I as a variable because it stands for an imaginary number. All right, so the way we're going to set this one up is it's called expansion by minors. Okay, so the first thing I'm going to do with this is copy this down 3 different times, and I do this because it's a 3 by 3 matrix. Now, what I want to go ahead and do next is I'm going to expand this by row. So I'm going to take this A, and this A comes out front, and this get canceled out. This one by B, and the rest of this row cancels out, and everything in the column beneath it is going to get canceled out, and the B is going to go out front. And the last one, the same thing with C. I'm going to bring the C out front. Everything below it gets crossed out, and everything above it. Now, this has a really specific pattern with signs. This first term is positive, negative, positive. If I had more pieces inside here, I would go ahead and continue on. So what I would be left with now is this idea that the matrix that I have is just going to be A times the determinant of E, F, H, J minus B times the determinant of D, F, G, J, plus C times the determinant of D, E, G, H. So that would be how you do an expansion of minors. Let's go ahead and try one. All right, so the first thing I'm going to do is go ahead and copy this matrix over 3 different times. And one more time. I'm going to zoom these in just a little bit to make them a little bit smaller. All right, so I copied my matrix over 3 different times. Now for the first matrix, I take out the 2, cancel everything above and below it, and I'm left with 1, 4, and 6, and 2. The second piece, I'm going to go ahead and take out the 1. Remember, this next one has to be negative. The first one is, and take out anything in the row in that column. So then I have a negative 1 on the outside, and inside this matrix is 1, 4, negative 3, 2. And the last one here is going to be this as a 3. Take everything out in that row in that column. This one is positive 1, 1, negative 3, and 6. All right, so let's go ahead and start with the same matrix that we had before. This is still A, B, C, D, E, F, G, H, and J. In this method, what we do is we take and we rewrite the first 2 columns. So the first column here is A, D, J. The second column is B, E, and H. Now, with this method, what we want to do is we want to create these diagonals. So what we're doing with here is when we are going down, it is positive. Going back around the other direction would be negative. So I create this idea of this diagonals. My first diagonal is A, E, and J. Then my next diagonal would be B, F, and G. My third diagonal this way is C, D, and H. So that first one here would be A, E, and J plus B, F, G plus C, D, and H. Now, going down in the other direction, now I'm going through and I need to subtract. So the ones that we're going to subtract here are going to be in the opposite direction. I have G, E, and C. I have H, F, and A. And finally G, J, D, and B. So the ones I have to subtract would be G, E, and C, minus H, F, and A, and minus J, D, and B. Combining all of that, that will go ahead and give us the determinant of that matrix. So let's go ahead and try one. So if I have the matrix negative 2, 1, 3, 1, 1, 4, negative 3, 6, and 2. The first thing I do is I take and I copy those first 2 rows over. So that's going to give me negative 2, 1, 3, and 1, 1, and 6. So I'm going to go ahead and add going down. 3, once I'm adding going down, is going to be here. 1, 4, and 3, and 3, 1, and 6. So those pieces, if I multiply that up together, that's negative 2 times 1 times 2. I add that together with 1 times 4 times 3, and finally times 3 times 1 times 6. Now I go through and I subtract going the opposite direction. So I am subtracting negative 3 times 1 times 3, 6 times 4 times 2, and 2 times 1 times 1, or negative 3 times 1 times 3 minus 6 times 4 times negative 2, and minus 2 times 1 times 1. Alright, so what does that give me here? That gives me a grand total of negative 4 minus 12 plus 18 plus 9 plus 48 minus 2, or that the determinant of this matrix is 57. Now, I do know that the calculators that I have you had purchased for this class will do all of this for you. Do know you must show your work for all of these and expect questions that would have a variable inside the matrix so that your calculator will not be able to give you the final answer.